Hey everybody, this is Larry. This is me trying to click the button, but also it's day 27 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Today I actually did a bunch of exercises. I finally started doing cleans, so I spent about 2 hours at the gym doing cleans and just assorted stuff. Clean as in clean and jerk, like the Olympic cleans. It's something that I wanted to work on this year and get up to at least my body weight. But we'll see how that goes. And I ran 5 miles, only 3 continuous, with a warm-up mile and a cool-down mile. So yeah, it's okay. Like, I'm making progress. Do things still hurt? Yes, very much so. But at least it's to the point where it's bearable, and at least I'll finish the race this weekend for sure. Knock on wood, unless I get more injured. But definitely no PR, no PP. But yeah, all right. that's the quick update. Still struggling with a lot of stuff. And yeah, let's look at today's problem. Today we have 873, length of the longest Fibonacci subsequence. A sequence n is greater than or equal to 3. Okay. You have at least 3 elements in the subsequence, or in the sequence. Okay, Fibonacci E for I plus 2 is greater than n. Oh, okay. Or you go to, okay, whatever. What does this even mean? Oh, wait, what? Okay, I guess so. This is very awkwardly phrased mathematically, but maybe not. I don't know. Okay, so that means that, yeah, you have a sequence that of Fibonacci, really. But yeah, okay. Given a strictly increasing array, we turn the length of the longest Fibonacci. Okay, yeah. I mean, n is equal to 1,000 is actually, that means that we can do n square. Okay, not too bad. My next question might have been, are the numbers unique? It does not seem, oh no, it's increasing, right? Strictly increasing? Yeah, strictly increasing. So the numbers will be unique. The very basic thing to do is dynamic programming, right? Yeah, I'm trying to think whether I can do either better or just in general, really. Let's see. So basically, the tricky thing about this is that the most naive way to think about it, in terms of dynamic programming, or the simplest, is going to have two states, right? You have the previous number and then the previous number before that, and then maybe like maximizing the length, right? Of course, actually, I guess that is good enough, right? I was going to say that I think I messed up in my head at some point, because initially I was going to say that, but that's too slow because that's n cubed, because then for these two numbers, for example, you have to find a 3. But that's not true, because that's what I was saying earlier about the uniqueness, and because it is unique, you are able to find a number just in O of 1, right, by having a lookup table. And so that should be good for a DP, but I think even then that is actually more complicated, which is why I paused for a second to think whether what I'm about to say is correct, which is that no, Larry. Every Fibonacci sequence is uniquely determined by the first 2 numbers, right? I mean, okay, so that part is true. But then the question is, now that, I mean, I was going to say then you can construct all of it, but I don't know that that's faster, right? And the reason why that I'm not sure that that's faster is because yeah, because the way that I was going to go with that one is that means that for every 2 numbers as the beginning of an array, we can construct every, I was going to say that is that for every 2 numbers, that means that we can find the longest subsequence in O of n times, but as a result of that, that's going to be n cubed. That's too slow, right? But I think the combination of that and the DP will get us the answer. I mean, we can still do the DP, and the DP will be fine, because basically the idea, and I know that I'm not really talking in basic terms because I'm just trying to think things out, really. So maybe this is definitely not a good dynamic program tutorial if you're looking for that. But you can think about the initial, this is how I attack these problems, that if you think about dynamic programming, you have these states, and where you have like the, that's using this terminology of x sub I and x sub I plus 1, then you may be like, I don't know, so like maybe x1, x2, right? But then now that means that x3 is equal to x1 plus x2, and we know we could find this in index in one time, right? Or one time. So then we can do go of x2, x3 or something like that, right? So like 1 plus, and that's really it. And because that, everything is O of 1 and we have n squared states, that is good enough. It kind of surprised me a little bit that the start with every two number thing is n cubed, where dp is n squared. Honestly, but I mean, it's because we do duplicate work, but it is kind of, I don't know, and this is maybe an experience thing where it is just a little bit surprising to me. But you can actually hack that, right? So actually, what I would like to do maybe is just like array, right? And then yeah, so like for maybe x1 in range sub n, so I1 for the first index, and then I2 in range sub I1 plus 1 to n, right? Basically, to get the first two numbers, I1, I2, right? So that means that we have at least 2 as a sequence. Do we always have, oh yeah, return 0 if it doesn't exist. Remember that we need at least 3 numbers, right? So yeah, so here maybe we have best is equal to 0. Maybe we have, current count is equal to 2 for the first 2, and then now we go, maybe, oh, I'm a little bit, well, okay, fine, right? So x1 is equal to array sub I1, x2 is equal to array sub I2, right? And then, as we said, x3 is equal to array of I3. Wait, that's not right. I'm just kidding. Plus x2, right? And then now, yeah, and then if x3 is in array, then yeah, x1, x2 is equal to x2, x3, current increment by 1. If current is greater than equal to 3, then best is equal to max best current, and we are good, right? And of course, the problem is a couple of things, right? No, well, a lot of things. Actually, I forgot a few things, right? So, this is a while loop, right? Because where this happens, we keep going. That's what I meant to do, right? Yeah. So it probably works. I hope it does. I mean, oh, maybe it's a little bit slow, but it should work. Maybe not, because there's only 10 elements. Even the slowest algorithm shouldn't be that slow. Is there an infinite loop? Oh, I'm dumb. Yeah, I mean, you have to update x3. Yeah, so this looks good. Unfortunately, this is actually n to the 4th, right? Because this is n squared, pretty basic. This while loop, the while loop itself does a reverse O of n iterations. Technically, I guess it is actually smaller than that. I mean, you can say that there's a hard O of n if we have a lot of bits, or even if there's a mod or something like that. But the reason why it's not is because the bounds, it does go up to 10 to the 9. And how many Fibonacci is there to, well, Fibonacci grows at about 1.6, phi to the n, right? That is smaller than 2 to the n. So that means that n will be bigger when we get to 10 to the 9, and 2 to the n would be dirty. So 1.6 to the n, I don't know what it is, but even if you say 60, that means the loop does 60 times and not O of n time, right? So you are capped there a little bit, but it's still not great. And then the other part of the problem is that, well, this x3 in array thing is obviously, yeah, O of n to run. So we have to do something like s is equal to set of array, and then maybe we just do this, and then maybe we're good, right? So this will be a little bit faster. I'm going to YOLO submit. Because now I'm curious whether n squared times 60 or whatever that is would be fast enough. Honestly, I don't think it should be fast enough. But as I was going to say is that it may be fast enough only because Leetcode's inputs make it fast enough, right? Like, or the inputs are not tight enough to make it slow. But it's not a guarantee, and I wouldn't have necessarily, you know, be really confident about it during a contest. You can actually speed this up a little bit more. The key thing to note is that if given a sequence, right? So you have a sequence, right? 1, 2. Yeah, I was going to start with 1, 1, but I guess that doesn't make sense. 3, 5, 8, 13, 21, 34, whatever, right? Fibonacci. So the thing is that, okay, if you start 1, 2, then you get the entire sequence, obviously. But then the thing is that if you start at 2, 3, you don't, I mean, you also get the rest of the series, but you know that that cannot be the longest series because, well, you didn't do the 1. So that means that if we've seen 2 numbers before, then that means that we can early terminate, and that will never be the better answer because we've seen it before. And if we've seen it before, that means that we extended a little bit earlier before. So maybe something like that we can do. The only problem is that the lookup will be pretty not cheap as well because it is n square elements, right? And the problem with n square elements is, or n square space, is that it does take n square time to allocate as well and stuff like that. So yeah, so then here we can maybe do this. If x1, x2 is in scene, then we just break because, and this will I mean, maybe this will happen, but this will never happen, right? Because we're breaking early. Otherwise, yeah. I think that's roughly right. I mean, maybe I'm off by 1, but it should be a little bit faster. Like I said, it's not clear to me that it's super faster, only because of the allocation of time and all these things. But yeah, so I guess they'll actually end up being mostly the same, which I'm not super surprised either, because this one, like I said, this loop only does about 60 operations, right, or whatever it is. The log base 1.6 of n, or of 10 to the 9, right? Whatever that is. I should know that. There was a time when I used to know it, but whatever, right? But yeah. Anyway, that is all I have for this one. It ends up being n squared, and if you have a scene thing, then it is a hard n squared, right? Because that means that for every 2 starting number, we only do, because for every, if you look at the subsequence, if you will, if you look at the subsequence, none of the subsequence will be hit more than once, because of this scene thing. It's almost like DP, except for if DP, you don't even calculate whether it is better, you just early terminate. So that's basically the idea. Yeah, that is all I have for this one. Let me know what you think. Thanks for watching. What did I do 2 years ago? I am curious. It looks like I mostly did the same thing. Actually, I did very much the same thing. But, okay. Well, yeah. That is all I have for this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.